Alright, so here is 7.4 part 1. Let's do a quick review. If I have something like log base 4 of 16, how would I solve it? Okay, so I would say, okay, this is equal to y, so 4 to the y is equal to 16. Right, so we rewrite this as 4 to the y is equal to 4 squared. Since we have the same base, we set the exponents equal to each other, and I see y is equal to 2. Okay, now we're going to use this property of logarithms to actually solve some equations. So let's go ahead and solve this, right? We're going to do our little curly Q action. So I have 8 to the 4 thirds is equal to x. So remember, top dog in the house. So the top dog, the 4, stays under the house, under the roof of the radical. So I can say this is the same thing as the cube root of 8 to the 4th, or something that may help us, a little bit of the order, remember from chapter 6, I could say the cube root of 8 and then to the 4th power is equal to x. So the cube root of 8, what times itself 3 times, is 2. So 2 to the 4th is 16, and that's what x is going to be equal. And let's do a little reminder. How would you put this in your calculator? You have 8 to the power of 4 divided by 3, and that gives you 16. Alright, try out B. You can always pause the video and give it a shot yourself first. A little curly Q action. 16 to the 5 halves is equal to x. So I'll write this as the square root of 16 to the 5th power is x. The square root of 16 is 4. And so 4 to the 5th power is going to be 1024, and that is what x is going to be equal to. Property of equality for logarithmic functions. So, property of equality. If b is a positive number other than 1, then log base b of x is equal to log base b of y, only if x and y is the same. Okay, so similar to how we had like 3 to the x is equal to 3 squared. And we said as long as the bases were the same, we could set the exponents the same. As long as you're taking log of the same base, you can set the inside portions the same. So, log base 5, guess what? I can set x equal to 8. Set the inside equal. Alright, so let's go ahead and let's solve. Okay, so missing some parentheses. No worries. Okay, so since I have log base 4 and log base 4, I can set the inside portion equal to each other. So x squared is going to be equal to negative 6x minus 8. And let's move everything to the left side, right? So add 6x on both sides, add x. Now I have x squared plus 6x plus 8. This is equal to 0. Ooh, I need to solve for x. Remember, solving for x is factoring and setting each factor equal to 0. So looking for what adds to the middle and multiplies to the outside. This is from chapter 4. So adds to 6, multiplies to 8, that'd be 2 and 4. So I could have x plus 2, x plus 4 is equal to 0. Set each of these factors equal to 0. So x plus 2 is equal to 0, so we see x equals negative 2. And we see x plus 4 is equal to 0, so minus 4 on both sides, x equals minus 4. So I can have x is equal to negative 2 or negative 4. So I'll box my answers, but I need to double check, because remember, we can't take a logarithm of a negative number, right? You can't take log of a negative number. So I need to plug in and check to make sure I'm doing okay. So, what I mean when I say you can't take log of a negative number, just a little aside, can't take log of a negative number. So if I try to say like log base 4 of negative 16, right, is equal to y, 4 to what power? 4 to the y power is equal to negative 16. Right? It doesn't make sense because 4 multiplied, so 4 squared is 16, but it's not negative 16, right? Like, there's no answer. There's no y I could plug in, right? 4 to no power is ever going to be equal to a negative 16, so I can't take log of a negative number. So I need to check to make sure that the two solutions I found right here are actually going to work. So I'm going to take log base 4 of negative 2 squared, is that going to be equal to log base 4 of negative 6 times negative 2 minus 8. Okay, so I have log base 4, negative 2 squared is 4, is equal to log base 4, let's see, negative 6 times negative 2 is 12, 12 minus 8 is 4, log base 4, 4 is 1, is equal to 1. Alright, we're good. So this one checks out, we're solid. Now I must try negative 4. Alright, so log base 4 of negative 4 squared, is that equal to log base 4 of negative 6 times negative 4 minus 8. So negative 4 times negative 4 is 16, so I have log base 4 of 16, because a negative times negative is positive. Negative 6 times negative 4 is positive 24, positive 24 minus 8 is 16, so log base 4 of 16. So this is, 4 to what power is 16? Oh, 2. So you have 2 equals 2. It actually checks out and both of these work. It's not always going to be that simple though, unfortunately. Okay, let's try the next one. All right. Cool. So since we have the same base on both sides, I'll set whatever's inside equal to each other. Alright, let's move the 3x to the left side, so I have x squared minus 3x minus 10 equals 0. So what adds to negative 3 multiplies to 10? Well, this is going to be x minus 5, x plus 2. Right? They add to negative 3, they multiply to 10. Set each factor equal to 0. I get x equals 5 and x equals negative 2. And now we must check to make sure they work. You have to check. Okay, let's try 5 first. So I'm going to check x equals 5. So log base 5 of, okay, ready? 5 squared is 25 minus 10. And on the right side, I have log base 5 of 3 times x, so that's going to be 15. Log base 5 of 15 is equal to log base 5 of 15. Okay, you know what? Left side is equal to right side. We're good. I don't need to check anymore. Because the big one to make sure is you can't take log of a negative number. Okay. Let's check negative 2. Check x equals negative 2. So, alright, so log base 5, negative 2 squared is 4. 4 minus 10 is negative 6. Uh-oh. This is a no-no. I can't take log of a negative number. If I do it on the right side, all right, negative 2 times 3 is negative 6. So although the left side and right side technically are the same, right? Log base 5 and negative 6, you can't have a negative inside. You can't take log of a negative. So this is not an answer. We only have x equals 5 as our answer. Doesn't matter that, the left is, the same thing as the right. Doesn't matter that they're the same. What matters is inside, you can't take log of a negative number. Because no matter what exponent you put 5 to, it will never be negative. Right? If I put 5 to, the 10th, whatever, it's going to be a really big positive number. If I put 5 to the negative 10, okay, this is the same thing as saying 1 over 5 to the 10. Oh, okay, so it still is going to be positive, it's just a small number. This is why our asymptotes for growth or decay, right, they never cross the x-axis. We never had negative y values. Okay, and that's where we'll end the lesson for 7.4. So this was the actual notes, and then the next screencast is just going to be some problems.